picking back up in lesson 7.2, we're on this example 3. We answered, and I actually rewrote it in just so I'd have it to refer to, but we answered A, B, C, right? We're ready to start sketching with D. And you'll notice down in D, it says use the grid at the right to sketch the slope field for the values calculated for A, B, C. So in other words, kind of using the idea, you know, my idea of this problem is it's designed to help you kind of look for patterns and see things. So when you do it on your own, no, you don't have to plug in every single point. You can, you know, look for some connections. So I guess if I look back at A, the first thing we knew is that what? The 1, 1s. 1, 1 was negative 1. Negative 1, 1 was 1. So those 4 pieces, right? So we can go ahead and fill in those 4 pieces, if you will. And so at 1, 1, we had a slope of negative 1. And I don't know what order they had it, but I guess negative 1 up 1, negative 1 right 1. That was a slope of positive 1, right? Left 1 down 1 is your negative slope. Right 1 down 1 is your positive slope. And they were all slopes of 1, yes? Now, if you look up at A, the other thing it summarized is that quadrants 2 and 4 are going to be positive. So every slope we fill in, we can't really fill in specific numbers right now, but everything in those slopes or those quadrants are going to be positive. In 1 and 3, those are going to be, excuse me, negative slopes. Okay, so that's kind of the summary. We can't really fill in anything here. Now, if you look at B, we learned that anytime y is 0, so 1, 0, 2, 0, 3, 0, negative 1, negative 2, negative 3, those are undefined slopes. Okay, now, undefined slopes. When we talk about the slope of that type of slope, we talk about it being a vertical line, yes? Generally, though, I mean, I kind of want to in this one. I know a lot of times she says what her notes were saying is, okay, you don't put the vertical lines in. But in all honesty, I kind of think it would help us in this situation. I think I'm going to put the verticals in because I think it will help us see the picture a little bit better. So the idea that 1, 0, 2, 0, negative 1, 0, negative 2, 0, they're all going to have undefined slopes, so that's going to be a vertical slope, yes? Notice I'm not doing this on 0, 0. Because in this form, you're going to have 0 over 0, which is a fraction. No, okay? Now, the generalization we got there is any vertical line. The slope was undefined. And then the slope is 0. When is the slope 0? And we don't really have a chart for it or anything. But if you look back at the problem was negative x over y, right? If you remember, this was dy dx equals negative x over y. And so when x is 0, what's going to happen? When x is 0, the slope is going to be 0. So that's going to be at 1, 0, 2, 0, 3, 0, negative 1, negative 2, negative 3. Okay. And then the other connection, which is part C. Okay. 1, 1 had a slope of negative 1. We already filled that in, yes? 2, 2 has a slope of negative 1. It also shows us in the chart that negative 1 has a slope of 1, or excuse me, negative 1, and so does negative 2, negative 2. This actually goes out farther. What else could I put as those same slopes? 3, 3, and negative 3, negative 3. So that entire, and notice here, down there it said what equation would express the negative 1 slope. I feel like I have that backwards. Oh, okay, no. Okay, so right here, all these are the -1 slopes, yes? Sorry. Can you parallel this? What's going to happen on the other diagonal? What's going to happen here? If 1, -1 is a +1 slope, what do you know about 2, -2? It's going to be a +1 slope as well, yes? And so that whole diagonal will be. Yes, Connor?
Is the 3 just a pattern?
Yeah, it's part of the pattern. And you could plug it in real quick if you want. But the idea that if 2, 2, 1, 1, 3, 3, I know the graph that's in here goes out to 3, but the charts only went up to 2s. So, okay, now, that's really all that we know based on what we were told, okay? To fill in other values, it really comes down to, okay, you can set up a chart and start working through it, or you can just kind of work on using this right here, yes, plugging them in your head. And I think that's what I would kind of do. Okay, so if we're doing -x over y. Well, first of all, we already talked about all these are going to be negative in this quadrant, yes? Because it's going to be negative of a positive divided by a positive. So what we have to focus on is x over y. Well, what's x at the ordered pair 2, 1? What's x over y? 2 over 1, which is 2, yes? So this is a slope of 2. It's a little steeper. I feel like I made that a little too steep. If you go over here to 3, 1, what's going to happen? The slope's going to be 3 over 1. It's going to be a little bit steeper. Are you seeing what I'm kind of following along there? If I go up to the ordered pair 1, 2, if I do x over y, this one instead is going to be 1/2, so less steep. And we've got the 1 here at 2, 2. And then at 3, 2, that's going to be 3 over 2, so that's going to be steeper than the 1. And if you want to get particular, it's steeper than 1, less steep than 2. Easier said than done on these little marks, right? Ordered pair 1, 3. If I go x over y, that's 1 over 3, so 1/3. So a little less steep than 1/2. 2, 3, I'm going 2/3, so a little bit steeper than the 1/3, officially less steep than 1. There's your quadrant 1 slopes. Now, what do you know about the other quadrants? It's going to be the same idea, isn't it? Okay, so it's just a matter of whether it's positive or negative. If you go down here in quadrant 3, you're going to have all the same positive slopes we just did. And so, if we, right here at -1, -1, it was x over y, so 1 over 1. If I go over here, 2 over 1, 3 over 1. If I go down to 1, 2, I threw out the negative, sorry. That's 1/2, so less steep there. I feel like that one's not a very good one. And then over at 3, 2, that's 3/2, so it's steeper. Down the bottom row, x over y, 1 over 3, it's 1/3. And then we have 2/3, and then 1 there. The difference in the other two quadrants is slopes are going to be negative, yes? And so I just keep in my head, I'm just x over y, x over y. Okay, so this was 1 over 1, 2 over 1, we've got the steeper part, 3 over 1, even steeper. 1 over 2, so 1/2, there's 1, and then 3/2. Down here, 1 over 3, so 1/3, 2/3, and 1. And then your other quadrant. So we've already got 1, 1 filled in. X over y, remember, 2 over 1, so positive 2, or negative, I mean, and then 3 over 1, 3. Of course, yeah. And then here, -1 over 2, so positive 1/2. Then we have 1, and then we have 3/2. So a little bit steeper across the way. And then we have 1/3, 2/3, and 1. You're excited. Fun stuff, right?
This is horrible.
Huh?
This is horrible. Yeah.
Slope fields, they're just tedious. And I don't have a better way to teach it, unfortunately. Now, did you see the point of looking for some of the patterns, I hope? If you can find some of the connections as opposed to just plugging them all in, it does help a little bit. But when it came down to the end, I really just had to kind of go through and do, okay, x over y, x over y, x over y. So, okay. With that in mind, so that was D officially. Right there, when I ask you to sketch the slope field, this is the slope field. You don't have to do anything more than that if they just ask for the slope field. Okay? Now, E says, draw the particular solution that passes through the point 0, 2. So where is 0, 2? So I'm supposed to look at the slope field, decide what shape I see, what graph I see going on, and then I want to draw the particular version of that graph that goes through that point 0, 2. What is this? Do you see the circle? It is a circle. Now, think about it. If it's a circle centered at 0, 0, yes. I can't always say this, but in this case, do we know a few other points that will be on this that will help make drawing it easier? Because what do you know your radius is going to be here? 2, if we're on this particular version of the circle. Obviously, a slope field represents an infinite amount of circles. So, not that I really, want to rely on that, but the idea is that I can draw a circle a little bit better if I have, I'm trying to hit certain points. Does the curvature of the circle go with my slope field to an extent? I mean, that's the idea behind it, right? As my circle is curving, it is matching up with the slope field pieces near it. Okay? We can draw an infinite amount of other circles if you prefer. So this is a circle with radius of 2. And then F says, what is the equation for this solution curve? We're doing an equation for this solution curve. Well, officially we could integrate this, separate our variables and integrate. Or, what is the equation of a circle? We haven't done this enough, I know.
Pi bar squared.
No, not area of a circle. Equation of a circle.
Plus y squared.
What?
It's like x squared plus y squared.
Is it radius squared?
Got it? You tuck it into the need to know information bank there. Okay? Area of circle. Equation of a circle. X squared plus y squared equals r squared. So in this particular problem, we would be talking x squared plus y squared equals 4. It doesn't specify, it just says what's the equation for the solution curve. So x squared plus y squared equals 4 could be one. Or could you solve this for y? If we solve it for y, it's going to be 4 minus the x squared. And then if it's y squared, you're going to take the square root. And since I just took the square root, officially I need to say plus or minus. Because when I go to plug something on my calculator that I'm graphing, if I can't plug in the equation for a circle as a whole. I have to do it in 2 pieces. So the positive square root and the negative square root. Okay? Okay. At the top of the next page, there's 2 questions referring to what we've just been working at. Explain what happens to the slope values as you move from left to right with a fixed y value. And so basically, I'm going to stay on this page. So a fixed y value. Where are my y values? Those are my horizontals, yes? So if you look here, for instance, at when y is 3. I'm just picking that one to look at. But if y is 3, what's happening to my slope? Well, over here, we were what?
Decreasing.
Positive 1, 2/3, 1/3, right? So it's decreasing. But then what happens over here?
It's still decreasing. Or does it, well,
Does it increase?
I think it's increasing then, isn't it?
but it's a negative slope, so is it increases, but it's negative?
Negative 1/3, negative 2/3, negative 1. Oh, wait.
Because like
That's
it's,
not.
like the number's getting bigger, but it's,
That doesn't agree with what was in the answer key, though, but I'm seeing the point. Okay, wait a minute here. Sorry, I'm having a moment of confusion. Is that allowed? It's not supposed to happen with the teacher, is it? Okay, so this is a positive 1. I'm just going to write the values in. I need a visual. Positive 1, then what? 2/3, 1/3. Those values are all decreasing, right? There's 0. And then over here we're in negative. And it didn't ask, I mean, because then you're at negative 1/3, negative 2/3, negative 1, yes? Okay, so I'm disagreeing with what's in the answer key then. Why did that at the time make sense then? Oh, okay, got it. Just answered my own question. Okay, so we can agree. We're at the top of the graph, slopes are decreasing, yes? What happens when we go below the x-axis? Because what happens over here? This is negative 1, negative 2/3, negative 1/3, 0, 1/3, 2/3, 1. That's where my confusion was briefly. I forgot we've got to differentiate between the top half of the graph and the bottom half of the graph. So up here when y is positive, my slopes are decreasing, yes? Down here on the bottom half, when y is negative, my slopes are increasing. Agreed? Sorry, I had a brief moment of confusion, and I know that makes it hard for you guys, but... And I just picked the 3 row and then the negative 3 row to write it out.
What are the slopes in quadrant 2 decreasing?
Because 1 is bigger than 2/3 is bigger than 1/3. And then over here, negative 1/3, negative 2/3, negative 1. I mean, ultimately, we're counting down here. Is that? I'm getting confused too, Connor. Trust me, I'm getting confused too with all the negatives and everything. But
It was just, I wasn't.
okay, and so when we say decreasing, I guess as we go from left to right. Okay. So, okay, I'm going to write. I don't know what you've already written. So when y was greater than 0, so when we were in the top, then dy dx was, that was decreasing, right? Yeah. And if you want, you could, when we say that decreases, that is from left to right, if you will. Okay. And then if y is less than 0, so we're at the bottom half of the graph, then dy dx is increasing. And again, that is increasing from left to right. Then we have to go back to the other page and answer H. Okay, start looking at the next one. explain what happens to the slope values as you move up from the x-axis with a fixed x value. So that means we're only looking at the top half, right? So ignore the bottom half. What's happening as we are moving up? Here I've got 1, 2, 3 in these slopes, yes? Over here I've got wait, did I do that wrong? No. Yeah, that's slope of 1. No, that's 1/2, 1/3. There we go. 1, 1/2, 1/3. Over here we'd have 2, 1, 2/3. Over here I have what? 3, 3/2, and 1. In each column, what were my values doing? It was decreasing as we move up, yes? Okay. Other than, what's the one exception here? If we go in quadrant 1, we're going to have the same thing. The one exception is undefined at the, when x is 0, right? Okay. So, well, and I guess the other thing I need to mention, my slope at the x-axis, because it said as you move up from the x-axis, but at the x-axis that slope is undefined, so. So, I'm going to say that dy dx decreases as you move up. And that was if you look at each individual column there.
Sorry.
Yes.
For the positive side though, wouldn't it increase as it goes up?
Because it's negative.
True, maybe. Why don't I have that in my notes then? Did I just stop there in my brain and let's see. So here I'd be at 1. Let's see, these are negative values, right? I know you probably don't want to write it on yours, but I need the visual here. So these are negatives in this one, right? So negative 1, negative 1/2, negative 1/3, yes? Yeah, I don't know why I didn't write that in the notes, but I do agree. Because then over here, yeah. Okay, so similar to the last one, depends on whether you are less than 0 or greater than 0, yes? Thank you. Not on it today. So over here, this is going to be when x was less than 0. dy dx was decreasing as you move up. Then over here, it's going to be when x is greater than 0. dy dx is going to increase as you move up. One thing I can figure out is I interpreted that differently when I did it. Up the x-axis. I don't even know how I would have interpreted that differently. I give up. I don't know. Okay. Ready to do some matching? Okay. I honestly don't know exactly how you see slope field on the AP exam. However, multiple choice problems. I can see how that, you know, here's some slope fields. Which one goes with example 1? Or here's a slope field. Which equation goes with it? So I'm going to put these all on the same page here. And there's 8 graphs. There's 8 equations. Looks for some features that we can match up. Okay. Things to consider. Some of my equations only involve x's. Some of my equations only involve y's. Some of my equations involve x and y. Some of my equations have certain places the graph will be undefined.
And if it's undefined, then what is that?
There's no slope, right? So with that in mind, there's 2 graphs I think that might be a little bit easier to figure out. I don't know. You guys see anything you want to go for?
Call me crazy, but I
Okay, crazy.
I want to say 6E, 6 and E. I don't know.
That's what it's
6 and E?
I was thinking.
I disagree.
I was
Okay.
thinking 5 and E.
I, oh yeah.
Why might we want to talk about 5 and E?
Because you can't have the negative.
Yeah.
Yeah. So what's this saying right here? This is saying that,
no negatives.
wait a minute.
You put it
Yeah.
down there.
Well, okay, so this is saying that y does not exist when it's
Yes.
negative, right? So this is saying, by looking at this, y cannot be, I don't know, I should have written that differently, cannot be negative, okay? Why, looking at 5, can y not be negative? Natural log, yes?
Okay.
So I'm going to agree, and I'm going to label it both ways so we know that that one is used and we're not going to use it again. Okay? And that also, y cannot equal 0, yes?
Yeah.
Which, right there. So really what I really should say here is that y has to be greater than 0. It has to be positive, yes? And we know with a natural log function, y has to be positive. Okay. We got 1 down. 7 more to go. Miles?
It's 1 D.
One.
Say that again now. 1
D.
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 Why?
Because you can't have the negative in the square root.
Okay. So if we look at 1, the value under the radical, x plus 2 has to be positive, yes? If x plus 2 has to be positive, it has to be greater than 0, which means if we subtract 2 over there, x has to be greater than negative 2. We're kind of thinking like domain type things, yes? And what do you notice about D?
It kind of cuts off.
It cuts off. We don't know at what number, but it would make sense that it cuts off around negative 2, doesn't it? Okay, so this probably goes with the idea that x is greater than 2. Okay, we got 2 of the easier ones out of the way. And from here, I would look for some patterns maybe. You could also look and think, okay, what's the integral going to be? Do I see that shape? Might be easier to start with some of the ones where it's just x or just y. Because remember, if it's just x, then your x columns are all going to have the same slope. If there's only a y, then you're going to have the same horizontals because your y values are going to be the same. Is there another one we want to take a guess at? I mean, I could stand here and tell you these, but that doesn't help. I need you guys to kind of look at them a little bit. So, let's see. Okay, I'm gonna let Jacob take it because I saw Ethan's hand, I saw Miles' hand, but Go ahead, Jacob. What's a guess?
Actually, let them guess first, because I'm not entirely
Well, you know what? I'm
Huh?
already 100% for missed attempts, so you know what? Let's try it. I'm gonna say H and 4
Why would you say that?
because the H looks like a sine graph, and so when you do the derivative of sine, it becomes
Does that make sense? Because here's the deal. If this is cosine, right? And so then if we go back and say, okay, what is the actual equation? So this is the derivative. So if we integrate, that's a sine. Or if you take the derivative, it's a sine, right? You know, some type of sine curve. Other thing is there's only x's here, right? So that means when you plug in x values, you're going to have a consistent curve. There's no y values to plug in, so the y values, you're not going to have anything change there. Okay, so
I have a guess.
Connor, did that take your guess? You want to do yours or you want Megan to
I don't know
go?
if I'm doing it right. Do you do the integral? Do you integrate these?
Officially, it'd be integrate if you can. And that's the thing, not all of them can nicely integrate. You know, like it worked well for the one we just did. I'm not sure it works for all of them.
I think C is 6.
I think C is 6.
Because if you integrate y squared, you get
That was my guess.
that
Like
was
So
my
we're-
guess as well.
Okay.
now it's like one of those cube graph things.
Okay, I can go for that. Okay, so 6 being C. So he's looking at the idea if we integrate it, we're going to be up to y cubed, right? Now, so it's going to be a y cubed thing, but that's also then the cube root, right? The other thing we can look at here, notice my y values, right? We're plugging in y, so y values across the board are going to stay the same. Okay. So that's one that you can look at. There's no x's, it's consistent y's. This one, I agree, we saw a sine x curve. So, since there's no x, we had consistent y's. Okay. Halfway there, guys. Which that means we have the easy half done, right? What left to do here?
B 7,
What'd you say?
B and 7,
Why?
because I put like 1 into x, and like 1 and 1,
Uh-huh.
so it's gonna be negative,
Okay.
and then as you increase the y, so we'll get more same.
Okay. And when I looked along this one, because I'm agreeing with her answer, what I looked at here also is you can look at each quadrant. Each quadrant has a different signed slope, if you will. Okay. And I, you know, kind of like Megan, if, you know, you plug in 1, 1. Okay. No, the thing is, they're not labeled. They're not labeled on purpose because they don't want to give you specific values that you can use to pinpoint. But if you plug in 1, 1, you're going to get a slope of -1. Could that be in the ballpark there? Yeah, it could. Okay. If you plug in any positive ordered pair, you're going to get a positive slope, or it's going to turn around, you're going to multiply by negative, it's going to be a negative slope. As you get a bigger x or bigger y value, you're getting steeper slopes, aren't you? Okay. So, yeah, I went for the fact that I have a negative slope, I have a positive slope, and negative slope. So kind of like the circle one we just did, right? I looked at the idea that, okay, every slope there is negative or positive. So, okay. Maddie, you got a guess? Could, what was it?
FB8.
FB8. Why?
I don't know. It just kind of looks like H, and then you have the X, so then they would be changing.
Okay. I don't know if anyone has a better reason than that, but I'll be honest. I think 8 and F was the last one I filled in because I don't have any comments written down on mine as to like why to verify that. Obviously, you know, you see cosine. Now, when it's cosine of x plus y, is that going to look exactly like a regular cosine curve? No. I honestly don't know what it looks like off the top of my head, which means I don't necessarily expect you guys. But, so we're not going to have, and what do we have left? We have, what, 3 left here. And I could rule out A automatically. So that means I'm down for 8, because it has x and y in it. I'm down to F and G. And then at that point, if I start plugging in some values, I think there were some values I plugged in that I found something happened. I'm trying to remember. There's some kind of values that I think I just kind of started plugging in. I wonder if I looked at maybe something along the axes or something. I don't remember, but okay. Well, at this point, we've got it, don't we? What do you got, Connor?
I think A is 3
Why?
because the integral of sine is negative cosine, and I feel like I've seen a cosine curve or something along a cosine curve look like that, and it's negative, so it's not going the opposite way.
Okay. Now, I will say the catch here, though, is it's sine of y. What's cosine of y? I have a reason to argue that one, though. Set aside from that. Why am I going to argue that 2 and A?
Because 2 has X's in it only, and A's and X's. Because it's
Okay.
all the same concept.
Yeah. The only reason I'm going to argue, so 3 has x and y. And if 3 has x and y, that means my slopes have right to go like there's not necessarily kind of like this one here. There's not a consistency, like I don't have everything the same on a vertical line. I don't have everything the same on a horizontal line. They're all over the place. Here, if we start looking at our verticals, like all those slopes right there are the same, yes? All these slopes are the same. Well, what are these lines that I'm drawing? These are not what I was meaning to write, actually. These are x values, if you will. So like, a line like that is a row of x. That is a row of x values, if you will. Because like this could be when x is 3. Because it'd be 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. And so I'm looking for something that only has x in it. So maybe I could say rows of x values. And so that means I'm looking for something that has no y because I have consistent x values, if that makes sense. And so for that reason, I would say 2 is A. However, I can wholeheartedly see that cosine curve. But the catch is it'd be cosine of y. And I really don't know it changes it, but I don't know. I'll have to think that through. Now, process of elimination. Three has to be G, unless we've messed something up along the way, right? What did I look at on this one? Okay. I looked at when y is 0. What do you know about the sine of 0? Sine of 0 is 0, yes? So if I look at my ordered pairs that are 0, comma, x values, well, 0, comma, x values are going to be on my y-axis, yes? So, for instance, at the ordered pair 0, 2, what's the slope supposed to be? Well, if I put in 0 here, that's 0 plus 2, 0, 2. I just said that. I'm on the wrong axis, aren't I? Oh my gosh. Okay, on the x-axis there, because they're x values, so when y is 0, x-axis, so like if I look at the ordered pair, like right here, that strikes me as that could be the ordered pair 1, 0. Well, sine of 0 is 0, plus 1 puts me at 1, 0. If you watch, my slopes are getting steeper over here. And it'd always be 0 plus a number. If I watch over here, my slopes are getting steeper as I go negative, but they're in the negative direction. And so, and there was, basically I picked a test point. So I said like, okay, at the ordered pair 1, 0, my slope is going to be 1. At the ordered pair 2, 0, my slope is going to be 2, so on and so forth. And I can't write right there. So you can pick key points to try and do some guess and check with. Okay. Okay. Got somewhat of an idea there? Some things to look for? You get 6 matching to try on your own at homework. So, I would definitely try them without looking at the answer key, obviously, right? Like, I was trying to have you guys try these without, like, I don't want to tell you anything. I don't want to lead you. Okay, are you ready for example 5? Maybe. Example 5. A differential equation, a point, and a slope field are given. Use the slope field to sketch a particular solution through the point. Then use integration to find the particular solution of the differential equation. Okay, crew, what do you see happening here? Okay, so do you kind of see that, like, there's very possibly... Okay, realize I did not just draw those in to be slopes. Those are, I was drawing the idea of an asymptote in, yes? That's what I was drawing in. I realize now, I'm like, oh, that doesn't look like an asymptote on a slope field. It looks like slopes. Okay. What's the graph look like? You see it going over there? Now wait, it gave us a particular point, didn't it? Yes, I better pay attention to that particular point. It wants me to attempt to draw something through the point 0, 1. So what's this doing? Doing something like that, right? So you're probably going to run along down the asymptote and do something like that. Not perfect, but you get the idea. Okay, let's go over and use integration to see what we get here. dy dx, what are we doing? We're going to take the x's and y's and separate, right? Which leads us right into tomorrow's lesson. So if I want x's on one side, y's on the other side, so I'm going to keep dy over here. And it's going to be 1 over x plus 2 times dx. I've got them separated, so now I'm going to integrate. What's the integral of dy? Or what's the integral of 1 in respect to y, I should say? What? Integral of 1 over x plus 2. So I can give you a hint here in a moment, but
What is the natural log?
I was just going to say, so what if the plus 2 isn't there?
Natural log of
Natural log of x, right? If it's just 1 over x, it's the natural log of x. So what if it's 1 over x plus 2? Natural log of x plus 2. And we can do that. I did that without u substitution because I'm kind of thinking, okay, is there a derivative of x plus 2 that I would have to worry about? Derivative of x plus 2 would be 1. Nothing to worry about there. So that's why I can do that without u substitution. And then officially I need to say plus c. And we'll talk about the full plus c and everything tomorrow. Now, that right there is a general solution. It wanted a particular solution through that given point. So what am I going to do? Plug in. So 1 is y, natural log of 0 plus 2 plus c. So 1 equals natural log of 2 plus c. So if you will, c is 1 minus the natural log of 2. And that's our c value. And so when I write the actual equation, y equals natural log of x plus 2 plus 1 minus natural log of 2. It is. And I'm realizing I always do lowercase natural logs. I've noticed in the answer keys you see capital L's. I'm understanding why.
Yeah, mine look all the same.
And I always try and make my L's curve a little bit, but totally getting why you would do that. Okay. I should have written these in ahead of time. So the last part is just some strategies, tips of how to distinguish. Yeah, tips and tricks there. What strategies and trends look for. So one thing we talked about was if dy dx has x only. Well, if it has x only and there's no y values, the y values isn't affecting it, right? Why do I feel like these are written wrong in my notes? Dy dx has x. Okay, I have written down slope changes from left to right only, as in the verticals are consistent. You can write what you want. I'm going to actually write both, I think. So in here I have slope changes from left to right only. And if you want to, what it means is, yeah, verticals are consistent. Feel free to put in your own words, add your own words, you know. I'm obviously having struggles in this lesson. And what else? What's the second one going to be? If dy dx has y only. So now what's going to happen? Slopes are going to change up and down only. And if slopes change up and down only, that means your horizontals are consistent. The third one goes right along with those two, and that is if dy dx has x and y. Well, if dy dx has x and y, the slope is going to change in both directions, right? It's going to change as you move across and up and down. So I'm going to say slopes change in both directions. Okay. Don't remember what else. Okay. When we were back a couple of that, when we had to draw the circle, we also looked for, on a couple of them, when it's negative versus positive, right? So when the slope is less than 0 or greater than 0. So find what conditions, when is my slope going to be negative, when is my slope going to be positive. I have that written here is find what conditions will make the dy dx less than 0 or greater than 0. So positive or negative there, right? So find what conditions will make dy dx less than 0 or dy dx greater than 0. As in what conditions make your slope negative and what conditions make your slope positive. To go along with the whole negative and positive thing, where is the slope? What's my other thing? Where is dy dx undefined or 0? Okay. If you want to throw a number 6 in, I mean, once you go through kind of your checklist here, after going through your checklist, it's just check specific points, right? Pick like on that one that there was one of them that was what, sine of y plus x. I tried to find some specific points to check and see what was going on there. And so, you know, don't be afraid to do that. Check specific points in each quadrant. Okay. I mentioned this yesterday, and I'll mention it again because it threw me off. I did 1 through 6. 1 through 6 just says draw the slope fields. Okay? When you look at 1 through 6 in the answer key, there's going to be more than just the slope fields on there. Okay? So don't let that throw you off, because then you go to 7 through 12, and it says to solve each and find the particular solution, and then it wants you to go back and sketch that on the slope field. Okay? Now, sketching on the slope field is kind of like what I just did here. Okay? But those sketches are back on there when you're just then doing the slope field. So just kind of FYI, 1 through 6, 7 through 12 go together. Connor?
If it's sine of x or cos of x or cosine of x, how would you do that? Because it's sine of...
You kind of want to pick key points. Like earlier when I was talking about that one, I was like, okay, I know 0, right? So I looked like it's sine of 0. Past that, it does get a little bit hard because we know where 0 is. You don't always know where all the others are. Keep in mind, if you pick something like pi is going to be 3.14. So you're going to be looking around 3. So you can pick some numbers like that to kind of give you an idea if that's what you're looking at. So, okay guys, good luck. See what you can do with it.
Sergeant, I would like to turn myself in. I forgot.